Welcome back. Today we're going to talk about different types of data, and as we start to look at the different types of data, this is going to lead us into discussions of how do we display that data and what are some of the things that we can do with different types of data. So the first thing that we need to understand is in problems and statistics, there's things called variables, things that change, things that can vary, and there's types of variables. The first one that we're going to talk about is categorical. The best way that I can describe a categorical variable is to tell you some examples of categorical variables. So, for example, I could ask you a question, and it would be, what type of dog do you have? Well, the data that gets spit back, the variable, the thing that varies is the type of dog. So types of dogs, or the color of your hair, or whether it's true or false. Is it true that you believe is it true that you believe in I don't know, unicorns, whatever. Okay? Numerical data is also called quantitative data. And numerical data is based on numbers that can be spit back in the variable. So for example, how tall are you, right? So heights. Or AP scores. Or how many touchdowns, right? How many touchdowns did a team score? And so quantitative data, numerical data, is displayed a little bit differently potentially, and we can do some things with it that we can't necessarily do with categorical data. Not to say that categorical data isn't significant or important, but they're just different. Key features of each of these. When we look at these different types of data, we can do different things with each type. So let's look at categorical data. Categorical data, we're going to look at the relative number of observations. For example, when I look at so I ask you, what color hair do you have? I might say something like this. Well, after surveying people, I realized that there's an overwhelming number of people who have blonde hair. Or most people have brown hair of the group that I asked. So the relative number of observations says, given the different categories, which one had the most, which one had the least, which one had close to average or whatever. Some of the key features of numerical data, we want to talk about the center, and that could be the mean or median. And we want to talk about the variability or the spread. And what that means is I said, hey, everybody in this class is tall. Well, what does that mean? Everybody in this class is over 6 foot. Is that true or is it not? Is there a lot of variability in the data? Meaning, do I have some people who are not 6 feet? Do I have some people that are 6 feet? And so as we look at variability or spread, we're actually looking at the data as a whole in comparison to one another. All right. So categorical data is also able to be clustered, and we can talk about the shape, and we can talk about the variability as well. And when we talk about the features of data, some things on the AP test are going to ask us to compare data or to describe data. And so we're going to start to see some of these words come up over and over and over. Center, shape, spread, variability, right? As we look at those things, we're going to learn some specific words to talk about them, but we're really looking at what does the data look like when I'm looking at a data display. So shape for categorical data would be, do the values cluster? Meaning, are they all around? So the class, most people in the class had a dog. So there's the number of dogs or the type of dog would be, a lot of people had German Shepherds or whatever. The center would look something like this. What was the typical observation? And variability. How tightly clustered. So how tightly clustered were they? Most people had 2 pets in their home. There were 2 types, blonde and brown were the 2 types of hair that were the most common. All right? When we talk about numerical data, we can talk about discrete data. When we're talking about discrete data, it would be like the number of pets you own. So that would be like I own 1 pet, 2 pets, 3 pets. Discrete data is like whole numbers, right? Or the number of kids in a class, number of students. Whole number data. Data displays for discrete data would look like this. I could have a bar graph, and if this was, you know, number of pets, then I'd have the frequency over here, right? There were, you know, 1 person with 1 pet, there were 2 people with 2 pets, 3 people with 3 pets, and nobody had 4 pets. Okay, so the number of pets is a discrete variable, and we can model it like that. We can also do, you know, some sort of like a dot plot, right? We could have, say, dot plots here where it says, oh, there was 1 person that had 1, 2 people that had 2, 3 people that had 3, whatever. Data can also be continuous. So if you can ask a question where the answer is 1, 2, 3, 4, or 5, whatever it is. You can also ask a question where there's an extreme amount of in between, right? So if I say, hey, how tall are you? I might say 6'3". Well, if I'm 6'3" and there's another person that's 6'3", aren't there smaller measurements? So we tend to round to, you know, the nearest ½ inch or 1/4 inch, whatever. But there's a lot of variability in there. So as to say that we've got different units of measurement, and we could break it down smaller and smaller. That's continuous data. And so some examples of continuous data, you could have height, weight, and time. Age would fall under there, mile times, things like that. So as we look at data displays that could model continuous data, they're going to look more like this, right? They're going to have more in-between values that are going to allow us to sort of split the differences between different times. So if a person runs, 2 people run the 100-meter dash, they might both have 11 seconds, but they might have, you know, 11.54 or 11.32 or whatever that happens to be. Common data displays that we see this fall into, you know, you'd have something that looks like this, and you have like the mean age or the median age. Okay, so when we look at this data, these are the types of displays that we're going to look at in the next in the coming sections. And so it's important when we break down data to understand where it falls. Is it categorical in nature, or is it quantitative in nature? That's going to allow us to use certain data displays to model it, but also to help us understand, like, you know, what's going on with these displays, what's best for it, and how does that help us interpret the data and what it's saying. All right, guys, thanks for watching, and we'll see you next time.